In section 3, we will solve quadratic equations by factoring. A quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a does not equal 0. We say that ax squared plus bx plus c equals 0 is called standard form. Use the zero factor property, which says that if a and b are real numbers, and if a times b equals 0, that means a is 0, b is 0, or both factors equal 0. Zero factor property. Here we have two factors, x minus 4 times x plus 2 equals 0. So using that zero factor property, that says that we can set each individual factor equal to 0 to find our answers. So we say x minus 4 equals 0. We solve the resulting equation, so we add 4 to both sides. The 4's on the left side cancel. We're left with x equals 4. That's one possibility. We now set the second factor equal to 0. X plus 2 equals 0. Solving for x, we did this in module 2. The 2's cancel on the left-hand side, and we have x equals negative 2. Quadratic equations by factoring. Step 1, we write the equation in standard form. Essentially, we want everything on one side of the equation and a 0 on the other side. Step 2, we factor the quadratic completely using any of the factoring methods we've seen in previous sections. Step 3, we set each factor containing a variable equal to 0. That means if we have a GCF that is just a constant, we can ignore it during the setting equal to 0 step. Step 4, we solve the resulting equations. And step 5, as is true in most sections, we can check each solution in the original equation to see if it actually satisfies the equation. Let's try an example. We want to solve x squared minus 5x equals 24. Our first step is to solve or rewrite our equation in standard form. To do so, let's move everything toward the side where we have x squared. I'm going to subtract 24 from each side. And when we do that, the 24's cancel on the right side, and that gives us our 0. On the left side, 24 is not a like term with the other two terms. So we rewrite it as x squared minus 5x minus 24. Don't try to combine the 24 with the 5x or the x squared. Now at this point, we go through the factoring process of x squared minus 5x minus 24. We see that there is not a greatest common factor other than 1. We also see that the coefficient of x squared is 1. So we don't have to go through the factoring by grouping process. We know x squared factors to x times x. We can now look at the last number and the middle coefficient. For the last number, we want two numbers that will multiply to give us negative 24, but that will add to give us negative 5. The only way we can get a negative product is if we have a positive number and a negative number. And as you go through and you find your factors, you'll find that you want 3 times 8. The 8 will be negative. 3 plus negative 8 is negative 5. So these are the two numbers we will use to fill in the binomials. This becomes x plus 3, x minus 8, and this is still equal to 0. Using the zero factor property, we can now set each individual factor equal to 0 and solve those two equations. We start with x plus 3 equals 0. We subtract 3 from each side, and the result is x equals negative 3. That's one solution. When we set the second factor equal to 0, we have x minus 8 equals 0. We add 8 to both sides. The 8's cancel on the left, and the result is x equals 8. So we have two solutions, x equals negative 3 and x equals positive 8. The equation 4x times 8x plus 9 equals 5. We start by simplifying the left-hand side, so we distribute 4x to each term inside parentheses. It gives us 32x squared plus 36x equals 5. So now we move all the terms toward the side where the x squared is, which is the left-hand side. So we subtract 5 from each side. The 5's cancel on the right-hand side and leave 0. On the left-hand side, we have 32x squared plus 36x minus 5. At this point, we need to factor the left-hand side. We start by looking for a greatest common factor, and there is none other than 1, so we can't factor out anything. And we also notice that the coefficient of x squared is a number that is not 1, so we have to use the factor by grouping method. It says we multiply the first and last coefficients together. That will give us negative 160. So now we want two numbers that will multiply to negative 160, but that will add to a positive 36. Now because the product is negative, we will have one negative number and one positive number. Because the sum is positive, the number furthest from 0 will get the positive sign. We see 160, and we know that 16 is 4 times 4. So 160 will be 4 times 40. The larger number gets the positive sign, so that's 40. So the smaller number 4 will be negative. And we know that negative 4 plus 40 is a positive 36. So these are the two factors we want to use in our factorization. We put those numbers in place of the middle term, and that gives us 32x squared minus 4x plus 40x minus 5 equals 0. We now group the first two terms, group the last two terms. 32x squared minus 4x has a GCF of 4x. So we factor 4x, and it leaves us with 8x minus 1. In the second group, 40x and 5 have a greatest common factor of 5. So we factor out a 5, and that gives us 8x minus 1. We now notice that each term has a binomial factor in common, 8x minus 1. So we factor that out, and the resulting polynomial is 4x plus 5. At this point, we set each factor equal to 0, because that's what the zero factor property tells us to do. So we start with 8x minus 1 equals 0. We start by adding 1 to both sides of the equation. That gives us 8x equals 1. We then divide both sides by 8. And we are left with x equals 1/8. When we set the second factor equal to 0, we have 4x plus 5 equals 0. So we subtract 5 from both sides. That gives us 4x equals negative 5. We then divide both sides by 4. And we are left with x equals negative 5/4. And those will be the two answers that satisfy this equation. Example, we want to solve 3x cubed minus 12x equals 0. Thankfully, our equation is already in standard form, so we don't need to simplify. We can go straight to the factoring step. When we look at the left-hand side, 3x cubed minus 12x, the GCF is 3x. So we factor 3x, and the resulting polynomial is x squared minus 4. Now, because the terms inside parentheses only have two terms, there's a minus sign in between them. The only possible way it will factor is if it is a difference of squares. So remember, in difference of squares factoring, each term has to be something raised to the second power. So we try to write it in that form. X is already in that form, x squared. 2 can be rewritten, 4 can be rewritten as 2 squared. And once we have the correct form, we write our two binomials. X will take the place of each first term. 2 will take the place of each second term. We add in the first, subtract in the second. Now in this equation, we have three factors that contain a variable. 3x, x plus 2, and x minus 2. So we have to set all three of these equal to 0. We start with the first. We have 3x equals 0, so we divide both sides by 3, and that gives us x equals 0. That's our first answer. We then move to the second factor. X plus 2 equals 0. We subtract 2 from each side. The 2's cancel on the left, and we have x equals negative 2. That's our second answer. And we set our third factor equal to 0. We add 2 to both sides, and it leaves us with x equals 2. We want to solve x plus 4 times x minus 12 equals 5x. Before we can write the equation in standard form, we have to simplify the left-hand side. We do so by foiling. So we draw our FOIL arrows, first, outer, inner, and last. The first product, x times x, is x squared. The outer product, x times negative 12, is negative 12x. The inner product, 4 times x, is 4x. And the outer product, 4 times negative 12, is negative 48. We combine like terms on the left-hand side. That gives us x squared minus 8x minus 48 equals 5x. Then subtract 5x from both sides of the equation, and we are left with x squared minus 13x minus 48 equals 0. Now that we have moved everything to one side of the equation and set it equal to 0, we want to factor x squared minus 13x minus 48. We see that we don't have a GCF that we can pull out other than 1. The coefficient of x squared is 1, so we know that the left-hand side, if it is factorable, the first terms and each binomial will be x. To find the second term, to look at the constant at the end and the coefficient of the middle term. Our two factors must multiply to give us negative 48, but add to give us negative 13. As we start looking at the factors of negative 48, we have 1 and negative 48, which gives us negative 47. That's not good. 2 and negative 24, which will add to negative 22. We're closer, but still not there. 3 and negative 16. 3 times negative 16 is negative 48. 3 plus negative 16 is negative 13. So these are the two factors we will use to fill in our binomials. So we have x plus 3, x minus 16, and that equals 0. Using the zero factor property, we now set each factor equal to 0. That will give us x plus 3 equals 0. Subtract 3 from each side, and we are left with x equals negative 3. So that's our first solution. We also have x minus 16 equals 0. We add 16 to both sides of the equation. The 16s cancel on the left-hand side, and we're left with x equals 16. Let's try another example. We want to solve 2x squared equals 3x. We first need to put this in standard form, so we move the 3x to the left because that's where our x squared term is. So we subtract 3x from both sides. These are not like terms. So on the left side, we have 2x squared minus 3x. On the right side, the 3x's cancel. On the left side, remember the first step to any factorization is to factor the greatest common factor. So we factor out an x. We're left with 2x minus 3. And that's all the factoring we can do. We have two factors. We set each of those equal to 0. The first factor is just x. So when we set up the equation, we've actually found the solution, x equals 0. The second factor is 2x minus 3. So we have 2x minus 3 equals 0. We'll start by adding 3 to both sides of the equation. That gives us 2x equals 3. We then divide both sides by 2. And we're left with x equals 3 halves. Let's try another example. Here we have binomials being multiplied on both sides of the equation. X minus 6 times 2x plus 2 equals x plus 4 times x minus 3. Here we are going to FOIL on each side of the equation to simplify before we try to write in standard form. So on the left side, we draw our FOIL arrows. And this will give us 2x squared plus 2x minus 12x minus 12 equals, let's do the same thing on the right side of the equation. So we draw our foiling arrows, and that gives us x squared minus 3x plus 4x minus 12. We're going to combine like terms on each side of the equation. On the left side, this becomes 2x squared minus 10x minus 12 equals, on the right-hand side, we have x squared plus x minus 12. Now here we have x squareds on both sides of the equation. In this case, let's just move all of our terms to the left-hand side. So we can do that one at a time or all at once. I'm going to change all of my signs of my terms on the right-hand side so that I can move them to the left. So I subtract x squared, subtract x, and add 12. Let's do that on both sides of the equation. That will give us, on the left-hand side, 2x squared minus x squared is x squared, negative 10x minus x is minus 11x, and a negative 12 plus 12, those cancel, it becomes 0. Equals, everything cancels on the right-hand side, so x squared minus 11x equals 0. At this point, we try to factor the left-hand side, so we can take an x from both terms, that's the GCF. This becomes x times x minus 11 equals 0. And there's no more factoring that can happen. So we have a first factor, which is x, a second factor, which is x minus 11, and we set each of these factors equal to 0. When we do that, the first equation gives us a solution right away, x equals 0. That's one solution. When we set the second factor equal to 0, x minus 11 equals 0. So we add 11 to both sides. The 11s cancel on the left-hand side, and we are left with x equals 11.